My name is Courtney Akagi, and this is my presentation on why the gravity of a black hole is so intense. First, what is gravity? It's the force by which a planet or other body draws objects towards its center, where gravity is the strongest. Gravity is what keeps our feet firmly on the ground and the Earth orbiting the Sun. Gravity is determined by an object's mass rather than its size. Mass is defined as a measure of how much matter an object has. To show the difference between mass and size, I'm going to use astronomer Phil Plate's example. If you take a piece of paper and crumple it up, you can see it's about this big. If you crumple it up further, the size gets smaller, but there's still just as much paper, or mass, as there was before. The mass doesn't change, and therefore the gravity doesn't change. So what does this have to do with black holes? Well, a black hole is defined as a place in space where gravity pulls so much that even light cannot get out. So how is something so powerful created? To answer that, we need to talk about stars. More specifically, how they die. When a star dies, it becomes one of three things: a white dwarf, a neutron star, or a black hole, depending on its mass. To keep things simple for this video, I'll only be covering the most massive stars, the ones that become black holes. While a star is alive, it creates energy by using a process called fusion, which converts lighter elements such as hydrogen and helium into heavier elements in its core. This fusion energy pushes outward, while at the same time the enormous mass of the star causes gravity to push in towards its center. When the star runs out of elements in its core to fuse, it loses the energy that was resisting gravity. Without that resistance, gravity overwhelms the star and it collapses in on itself. This causes the star to explode in a huge burst of energy called a supernova. When the explosion settles, all that remains of the star is an inescapable black hole. So now that we know how gravity creates a black hole, we can return to our original question. What makes the gravity around a black hole so intense that not even light can escape? In reality, a black hole doesn't have any more gravity than a star with the same mass, because mass determines gravity. So why can light escape a star, but not a black hole? The answer lies in its density. Earlier, we talked about how the closer you get to the center of an object, the stronger the gravity is. If you compare a star and a black hole with equal mass, you can see that the gravity reaches just as far for both. The difference is that a black hole's mass is much more dense than a star's is. This means that if you were to stand on the surface of a black hole, you could get much closer to the center, where gravity is strongest, than you could by standing on the surface of a star. So to shortly answer the question why gravity is so intense around a black hole, it's because there is so much mass compacted into such a small size that you can get closer to the point near the center where gravity is so strong that not even light can escape.